SwayamPrabha. Digital India. Educated India.
In this lecture, we'll be discussing in brief of open loop control system and closed loop control system, and also be discussing how closed loop control system plays an important role over open loop control system. Then we'll move to this autopilot part, what are the different subsystems exist in the autopilot and how they are connected in closed loop. We'll discuss them briefly. Then we will conclude the lecture. Let's go with some examples where the control system plays an important role. Let's consider we have aircraft system and we want to maintain desired speed of the aircraft. This is the output speed of the aircraft. And here, the pilot is here in this block, for example, which is basically controller, we can say. The pilot is using the throttle, which can provide the desired thrust to the aircraft. Control input, you can say. This is the aircraft system. And we want to maintain a desired speed, which is the response is going to the pilot, desired speed. Or we can say desired output. Please note that this is the actual speed of the aircraft, but we want to maintain the desired output, desired speed. Now, the pilot asked to accelerate the aircraft to a particular speed, and we are assuming the pilot flying the aircraft in straight line. So we are assuming the pilot flying the aircraft in straight line. Here, flying in this fashion, the pilot does not have any idea about the actual speed because based on the input, control input, the aircraft is getting some speed. So it does not know about the actual speed of the aircraft. Such kind of system, if you look this kind of system, this system may work perfectly. This system, or I should say this control system, may work perfectly if the pilot knows the knowledge of the system. What does it mean? The pilot knows here what output the system will produce when a known input is applied. So it means the pilot knows the system perfectly only when we can get the desired speed of the aircraft. But if there are some uncertainties or disturbance come to the system, some disturbance or some kind of unmodeled dynamics or uncertainty in the system, the desired speed cannot be maintained because the pilot does not have any knowledge of the actual speed of the aircraft. So in this case, we can't achieve the desired speed of the aircraft if there is some disturbance or uncertainty coming to the system. But the pilot can achieve the desired speed if the pilot knows the exact model of the system. But due to this kind of input to the aircraft system, input means that uncertain disturbance, we can't achieve the desired speed. Again, if you have some wind to the system, which is acting opposite direction to the flight motion, again, it will give some disturbance to the system. So it means we can't get our objective. And this kind of system, you can say, this kind of control system where the pilot does not have full, or I should say, does not have the knowledge of the system response, we can say is the open loop control system. So based on whatever the response we are applying to the aircraft, we will get some output, but there is no means to correct that output. There is no means because there is no feedback in the system. And this kind of system we call open loop control system. Now, the pilot decided to verify the actual speed of the aircraft. So let's draw the figure again. So we have having controller here. Called pilot, and who is giving some control input to the plant, and we are getting the output speed. And if we have some kind of sensor, let's assume some sensor, and sensor can get the actual output of the aircraft system. And if you have some summing point here, some kind of mechanism where we can this is my desired speed, and this is the right. This is the error. Negative and positive. This is the error. And we can say this is the actual speed. If you denote, this is my y desired speed and this is y actual. So the E will be yd minus y. So based on the error, the pilot can decide how far from the desired speed of the aircraft, and accordingly, the pilot can control the control input to the plant, and based on which we can modify the output response of the aircraft. This is how the this is basically this is the closed loop control system. So now here the controller subsystem because this is the complete system, and here we have different subsystem like controller, plant, sensor system. So controller also a system is the main design parameter in designing control system and determines how rapidly and with what maximum overshoot and undershoot the actual output, which is y in this case, will become equal to the desired speed, desired output. So this is how the control system work in the closed loop control system. We can modify the controller so that we can come up with that our desired output. Why it is overshoot, undershoot? Because once the system goes to a desired response, it may go with some oscillations. After some time, we can come up with our desired value. It should be noted that we should note some points here. When the desired output yd is constant, the controller acts like a regulator. So if you if the desired speed is constant, and if you design the control algorithm for the system, the controller acts like a regulator. And when the desired output is time varying, the corresponding control system is called a tracking system. So this is how in the closed loop control system we design the regulator or tracking system. If here the yd is constant to be tracked, it is the controller acts like a regulator. If the yd is time varying function, then the design controller will be like a tracking system. So now in control system, what are the different subsystems we are having and which can fulfill our mission objective. So control system, here control system means we are talking about the closed loop control system. In this course, since we will be designing the autopilot, so in the most of the design algorithm based on the closed loop control system. So generally depends, generally consists of three parts. One is navigation. So navigation talks about where my vehicle is, where the vehicle is. So it means navigation, basically, we can say sensor, all these things comes under navigation system. So navigation tells where the vehicle or what the actual speed, what are the conditions, output conditions. It measures those parameter, navigation. And second is guidance. Guidance tells where do I want to be. So guidance generally measure how far you are from the desired value. So this from this error function, we can comment how far the actual output of the aircraft from the desired output. So it is generally measure the error, based on the error it calculates. So this is how the guidance work. And third is control. This is the most important part. So control is how do I get there. So control will, so based on the navigation guidance, how far you are from the actual value, then control will take the effective action so that you can achieve the mission. So control, based on the error, controller will provide the command to the plant, and slowly we can come up with our desired value. Now let's look how these subsystems are connected in a closed loop. The navigation, guidance, and control subsystems are connected in a closed loop fashion as following. First, we can start from the navigation part. This is the navigation, which provide the estimated value, which provide the estimated value to the guidance. So this is my guidance loop, and navigation provide the estimated values to the guidance, and guidance generates the error, as you discussed, error, and this error goes to the controller, and controller provides ideal torque and force command, ideal torque and force command to the control, to the not to the control, to the actuators. So if it is, for example, if you are controlling the orientation of the aircraft, actuator could be your aileron, rudder, elevator. So the control algorithms gives the commands to the actuator. Commands means what angle these control surfaces, aerodynamic control surfaces, should be deflected so that we can get desired or applied force or torque to the aircraft, to the aircraft system. And yeah, so this is basically how actuators gives the values to the your 6 of model, so that we can control the position and orientation of the body. And from the aircraft system, we are having the true values. True values means it can be x, y, z, position of the aircraft, or phi, theta, psi, the orientation angle of the aircraft. So these values goes to the sensed by the sensor, onboard sensors. Some sensors are like accelerometer or gyroscope or IMU. These are onboard sensor which senses these states, and based on the sensed output, this output goes to the navigation platform or navigation subsystem. So this is we can say this is the measurements. This measurements goes to the navigation. So this is how the closed loop control system works practically. Now, if you connect to our aircraft system, this is what we have discussed here. Suppose we have, this is my summing block, where our input is, there will be two inputs basically. This is the desired values. So desired values can be your desired phi, theta, psi, or a position of the aircraft. And so I have, this is the error signal. Let me first draw the figure, then I'll explain. This is the controller, and controller output goes to servo system on the aircraft, servo system, and servo system generates the desired or the available torque or thrust, aileron, radar, elevator, and these values goes to the aircraft system. This is 60 of model. If you're assuming the full aircraft equation, this is basically 60 of model. And the actual output are sensed by onboard sensors, and the sense output goes to navigation block. So in navigation, basically we can come up with some filter techniques or some kind other some kind of designs where we can find the estimated values. And these estimated values goes to the summing point, negative, in negative loop. So why it's negative, we'll be talking later why it is negative, why not it's positive. All this thing will be covering. And so based on this estimate values, we can find the error. And this error signal goes to the controller, and controller can take the effective actions based on the controlled based on the control system. We provide the ideal values to the servo system. Servo system basically, you can assume the motor, what deflection we should have for providing the desired torque or force to the aircraft system. So this is how practically autopilot works. So this is basically autopilot design. This can be for aircraft, for the rotational motion or translational motion, or any other motions in the aircraft. So this is how we achieve our missions. Let's stop it here. We'll continue from the next lecture. We'll have some basics on systems, how we'll validate the system, whether it's linear or not, because most of those systems in this course will be considering linear system, because we'll be designing the linear controls for this aircraft. So our system should be converted into linear form, and we can apply the linear controls. So this is how we'll be moving. Thank you very much. We'll be continuing from the next lecture.